Apoptosis, or cellular suicide, is programmed cell death which integrates multiple cell pathways. Although the word suicide may have a negative connotation, apoptosis contributes to the development and maintenance of multicellular organisms. The process is composed of initiation, execution, and phagocytosis. Outside the cell, apoptosis is initiated by a death signaling molecule that binds to the receptor on the cell surface. As a result, a protein called SED9 is inactivated, triggering the activation of apoptotic proteins such as SED4 and SED3. Then the execution process involves the cascade caspase activation when signals from the proteins reach other caspases that chop up the protein and DNA. Thus, the cell shrinks and begins forming blebs in the cell membrane. Next, the cellular components get packaged into vesicles to be taken out of the cell. Finally, these vesicles are consumed and digested by lysosomes in the process of phagocytosis. The most difficult part to comprehend on apoptosis is the different ways that it can start or be initiated. It can be initiated on the outside of the cell by a death signaling molecule and receptor. On the other hand, there are two ways it can be initiated from the inside, with DNA being damaged and proteins misfolding in the endoplasmic reticulum. It can be confusing because of the fact that apoptosis can begin both inside and outside the cell, but trigger the same reactions. There are three main steps: initiation, execution, and phagocytosis. Apoptosis can start from three different pathways, one from outside the cell and two from inside the cell. Apoptosis is generally triggered outside the cell by a death signaling molecule and on the inside by DNA damage or protein misfolding. It initiates a cascade of suicide proteins that activates caspases and other enzymes to carry out apoptosis. For the execution, cellular components get packaged into vesicles to be taken out of the cell and digested. Phagocytosis is the digestion of the blebs by the lysosomes of the cell.